Hey coders, welcome to my channel where we learn all about web development by implementing project rather than making you go through another tutorial hell. And this video is all about implementing security verification through Sliding Captcha. So basically Captcha represents a completely automated Turing test. The purpose of Captcha is to deter automated bots and to make sure the entity that is trying to access this website is actually a person rather than an automated bot. There are different types of captchas that we can implement, such as text-based captchas, image-based captchas, behavior-based captchas, mathematical captchas, and this particular one that we are going to implement today, which is called sliding captchas or slider captcha. This kind of captcha is getting very popular nowadays. In particular, if you have been to TikTok, you must have seen a version of this type of captcha. This particular image that is being shown over here is actually a security verification captcha at the Temu website. So if you open the Temu website for the first time, you will be redirected to a page which contains this kind of puzzle. Now, if you notice, there are two puzzle pieces that are missing and we have only one piece given to put in either this part or this part. If you correctly put it in this part, you basically pass the verification test that you are not a bot, rather a human. However, if you place it anywhere else other than this part, you basically fail the verification test. And in order to move this puzzle piece, you have to slide it over here. If you slide it over here, this puzzle piece will keep moving towards the left side. You can't move this puzzle piece anywhere other than in the horizontal direction and towards the right. Now let me show you the demo project that I have already implemented for you guys. Okay, so this is our image and this green block represents the empty piece on which we have to put in these two puzzle pieces. So if we select this red square box and put it over here, we will pass the security check. However, if you place it somewhere else other than this square box, we will fail the test. If we choose the circle and move it in the square box, we will again fail the test. And at the bottom over here, you can see the slider. So by default, this square box is selected. Let me move the slider and put it over here. And it says puzzle solved. That means you have passed the verification. Let's refresh. Put it somewhere else. It says try again. That means you failed. Now let's select the circle rather than the square box by clicking it. Let's move it. Even if you place it on top of the square box, the placeholder where we are supposed to place the puzzle piece, because the shapes don't match, we will fail the test. Now it says try again. So this is the project that we are going to implement today. If you like this project and you haven't already subscribed to my channel, click on that subscribe button down there as well as hit the like button. And I would love to hear your thoughts as well. Okay, so let's get started now. Now this is our project folder. If you notice, I have already got the images, the balloon image that we are going to use. This one. Then we have index.html. I'm going to explain the contents of this file in a bit. But we have also an empty script file as well as the styles file. The style file as well as the script files have already been linked over here. This is styles file and this is the script file. Both of them are empty. However, the contents of this index.html file are, so basically in the body we have h1 with a title called sliding captcha. Then we have a sub which says slide to complete the puzzle. So sub means subscript. It's going to place the contents little below the horizontal axis of the line where these contents were supposed to go. And by default the font size is also smaller. Then we have a div called container and the rest of the contents are within this div. Now this div called container has two children. The first one has been given a class name called puzzle container and the second child has been given a class name called slider container. So basically the puzzle container contains this whole div and these boxes and circle. However, the slider div contains this slider. Now let's go through the contents of puzzle div. So basically the puzzle div contains four children. The first one of them is an image over here, balloon.jpg, and this is the alternate text and we have given it an ID called puzzle image. Then we have a div with the class name puzzle piece. This represents the square piece. This one over here. Let me refresh. Okay, so puzzle piece with the class with the ID puzzle piece as well. Basically this div is empty. Then next to this puzzle piece we have another empty div with the class name circle. Then the next child of this puzzle container is a div called circle piece and it has the same ID as well. After that we have another div called target area with the same ID. This square box represents the target piece. This is puzzle piece and this is the circle piece. These were the contents of the puzzle container. Now let's move on to the slider container. The slider container has just one input of type range. So when we use an input of type range, we get this slider. Now when you give this type range to any input, we get other properties as well, which is the minimum value, max value, the current value and the ID. So ID is basically associated with every HTML element. But the attribute unique to this input of type range is minimum value, max value and current value. So this part, the left area of the slider represents minimum value, and if we move it over here, this will be its max value. We can give them any min and max values. For example, rather than giving min a 0 and max a 100, we can start with, let's say, 20 and make it 100 or 120 or 100 or 150. It's up to us. But if we give them default values, which is min 0 and max 100, it will be much easier to do further calculations in our mind as well. And if we move the slider somewhere over here, then this is the current value of the slider. So that current value will be stored over here. So in the beginning, because the value is 0, the slider is exactly at the leftmost position. Now let's give it 20 and see it. How does the slider get placed if the default value or the initial value is 20? So let's refresh. Okay, so earlier I gave 20 to the project that we are going to build together. But because this is the demo project, so I was supposed to give 20 to the demo project, which I did. And now if we refresh, it starts over here. Now in our demo project, if I change it to, let's say, 60, now this is the default value where the slider will be placed in the beginning. Let's refresh and you can see it's there. So this is what the value represents, the current value where the slider is going to be positioned. Let me put it back 0. This is the project that we are going to build together. Okay. Now the first thing is, let's give it some styles. Then we will move on to the functionality. Okay, so let's start with the body. Let's give it display flex. Flex direction is column. Align item center. Let's give height 100% viewport height. Margin set 0. Font family. Let's select this one area. I forgot to give justify content center as well. Okay, so this is how it looks. The image is occupying the most of the contents. Okay, now let's work on the container block. So this is where both of our children are, the puzzle container as well as the slider container. Let's give it position relative for the benefit of its children. Let's give it width. Let's give it 600 pixels. Now let's move on to the puzzle container. So puzzle container. First of all, let's give it width 100% of the parent, and height is going to be as per the requirements of the content. So put it auto. Let's also give it margin bottom so that there is some space between the image and the slider. So margin bottom, let's give it 5 pixels. We will still not be able to see any changes because we haven't yet given any properties to the image. So as a result, it's occupying the most of the area like this. Now let's fix this image size so that we can see the rest of the contents as well. So let's go to index.html and okay, so we have given just ID to our image, which is puzzle image. So because it's ID, so hash puzzle image. It's actually whole image, AMAGE. Okay. So let's give it width 100% as well as height 100%, that is 100% of the parent. Then we have to make sure the image fits within those dimensions. So object fit and cover, that is no matter what happens, you have to fit in within the dimensions of the parent. Do not overflow out of it. Okay, so this is how it looks. Now let's style the puzzle pieces and the target area. So let's go down and we are going to define some common properties for both the puzzle pieces. So the class names were puzzle piece, comma, circle piece. Now the common properties are set position absolute for both of them. Now because we have given position, where is it? Container has been given the position relative, so these two pieces will try to position themselves with respect to the top left corner of this container. Let's give width 100 pixels for both of them, and height 100 as well. It's px pixels. Okay, now the next common property is going to be how far down they are from the top of this container, and it's going to be the same value for these two pieces as well as the target area. We have to make sure this value is same so that when these pieces slide over, they have a chance to fit over this target area. if we place them vertically at different places, they will never have a chance to fit on top of each other. So therefore, because the property has to be same for everything, I'm going to create a variable. It has to be global, so root block, and let's define a variable with the class with the name top, and let's give it 75px value. Now let's go down. For both of them, let's give them top. So this way both of them will have same value. If we change the value over here, it will be changed for both of these pieces. Okay, so these are common properties to both of these pieces. Now let's target the puzzle piece, that is the square piece. So we have already set position absolute and top for both of them. For the left, let's give it 10 pixels. So from the left, they are 10 pixels moved towards the right side. This is the square piece, okay? Let's give it background color. We give it a shade of red, so 255, 0, 0, and then opacity 0. Let's give it 5, 0.5. Okay, then for the border, let's give it solid 2 pixels and red color. Let's have a peek. Okay, the size is too big. Let's make it 50 pixels. Current value is width and height is 100 pixels. Okay, good. Maybe we should push it down a bit further. So let's go over here and let's make it 140 pixels. Okay, that's better. So this is moved down. And now let's style the circle. So the class name is circle piece. Copy, paste. Let's copy these, then we'll change the values. Okay, the left. So the square starts at the 10 boxes, so we have to move this one even further than the square. So let's make it 65 pixels. Background color, it's I think we have chosen blue, so the third value is going to be 255, and change the border color to blue. Now because it's a circle, so we have to give it border radius 50%. Okay, maybe we need to move this one a bit further because there is hardly any space between these two boxes. So instead of 60, let's make it 72. Sorry, instead of 65, we are making it 72. Yeah, I think that's better. Now we have to define the target piece. So the class name that we have given is target area. Target area. Position is absolute. Width 50% and height 50% as well, like the other two puzzle pieces. Sorry, if not 50%, 50 pixels, and height is 50 pixels. Again, we have to make sure whatever width and height we are giving to this box, it needs to match with these two puzzle pieces as well. Otherwise, they might never fit. Now for the background color. So first value is 0, then 255. Third value is 0, and the alpha value is 0.3. For the border, solid 2 pixels. Now because this is a placeholder, it's not a puzzle piece that needs to be moved around. The puzzle piece needs to come and fit into this box, this area. So we are going to give it different border so that we can distinguish between these three pieces. So let's give it dotted. Instead of dotted, make it dashed. It can't be solid and dashed at the same time. So 2 pixel dashed, and color is green. Okay, so this should be over here somewhere. Probably we haven't defined any top property. The top attribute. Yes, top and left both are missing. So for the top, we are going to take the value from variable top. And for the left, we have to move it further away from those two puzzle pieces. So the value should be, this is 72 for the circles. So for the left, let's make it 145 pixels and see the consequences. Okay, we need to move it somewhere over here. So rather than 145 let's make it 245. 345. Yeah, maybe 320, 25. Yeah, I think that's better now. Okay, so these were the styles for the puzzle container and its children. Now let's move on to the slider container and its children, which is the slider. So let's check the class names first. Okay, so the div has slider container class and the input has slider ID. So let's target slider ID first, and then if we feel the need, we will define some styles for this slider container as well. Basically, the only thing that we want to do is that we want this slider to stretch out and cover this whole area. So for that, let's target the input type itself with the ID slider, and let's give it width 100%. Okay, that's good. Probably we don't need to define any styles for the slider container. Okay, now we can move on to defining the functionality such that when we move the slider, the selected pieces, remember the pieces can be any of these pieces can be selected. By default it's the square box, but if we click on the circle will become the selected or active piece. So whichever is the active piece, when we move the slider, that piece will move, and the moment we let go the slider, then the calculation will take place, which will try to figure out if the active piece and this placeholder match. If yes, then you have successfully passed the CAPTCHA test, otherwise you must be a bot. Okay, so let's define this functionality. Now because this is a functionality, obviously it's going to be defined in the JavaScript. So let's go to the script and first of all get references to necessary elements from the HTML. And those necessary pieces are, we need a reference to this slider, these two puzzle pieces, and this whole container which contains this image and all of these pieces, all of these puzzle pieces, as well as the placeholder piece. So const, let's start with the slider, document query selector, and because the slider is a ID, so h slider, let's copy paste it. Now let's change the name puzzle piece, and it's called puzzle piece as well. So the puzzle hyphen piece, it's PIE. Okay, so this is puzzle piece. Now circle piece, let's change it to circle hyphen piece. Okay, now the last one is puzzle container. And the class name is dot okay, so we have references to these elements. Now let's define a variable called active piece. So this active piece will contain whichever is a selected piece which will move when the slider moves. So let's make this puzzle piece, that is the square box, the active piece. Okay. Now because this slider is actually an input element, so whenever we move this slider, the event that is triggered is called input event. So we have to capture that event and associate functionality with that event. So slider dot add event listener, so the event is input, and let's define a function, the callback function. This function will be executed whenever this input event is triggered, and over here we have to define the functionality. So what functionality do we need to define over here? So basically what we want is that whenever this slider moves, we want the active puzzle piece move along with it as well. Now in order to define this functionality, the first thing that we have to figure out is how many pixels are currently being occupied from this corner of the container to this corner. The second thing will be how many pixels are being occupied from this corner of the puzzle piece to this corner of the puzzle piece. Then from the total pixels occupied by this container, we will subtract the puzzles occupied by this box, the puzzle piece. Now even though this looks like a circle, but it's occupying the same width and height as this box as well as this box, but currently we are concerned with these two boxes. So anyway, once we know the total height, once we know the total pixels occupied by this box and the container, then from that container pixels we will subtract the pixels occupied by this puzzle piece. The reason is that when we are moving this puzzle piece, so we already know that it's 50 pixels. So when this box reaches this corner, this will occupy last 50 pixels. So suppose the total width occupied by this container is 450 pixels and this box is 50 pixels. So that means the slider should reach 100% over here once the box is placed over here, that is 400 pixels. So actually when the slider reaches here, let's say this is the 400 pixels. So when it reaches here, the slider should be over here because that space is needed to place this square box over here. So once the square box is in the corner, that means we have moved the slider 100% to its max value. So these are the first two steps that we have to do. So const max offset. Now, in order to get the pixel value occupied by the whole container, we have to say the container is this puzzle container. So puzzle container dot offset width minus this active piece dot offset width. So this is the first part, that now we know how much pixels are being occupied by this container minus the space occupied by the active puzzle piece. The next part is to map the distance covered by this puzzle piece with the distance covered by this slider. So we know that when the slider is at the top left position, its minimum value is 0, and when it reaches, it's 100. So it ranges from 0 to 100. Now we have to figure out how much pixels needs to be moved in order for the slider to move 1%. So basically, if the slider moves 30%, then how much pixels this box, the active box, which one of them it is, needs to be moved towards the right. Okay, so the first thing is to convert these values 0 to 100 into percent value by dividing it by 100. So let's give it the variable offset and slider.value divided by 100. So this is first part. So basically we have converted the percent values, which was 0 to 100, into some decimal value. For example, the slider is moved 10%. So this value will give us 10 and we will divide it by 100%. So that will give us 0.10. Sorry, it's 0.1. Okay, so this will be a decimal value, but we still have to figure out what does 0.10 means with respect to this offset value. So for example, 450 pixels are occupied by this offset value, then how many pixels represents 0.1%? So in order to figure that out, now we have to multiply this whole thing with this max offset. So now we have successfully mapped the percentage values of the slider with respect to the pixels or distance that needs to be covered for the container, this container, with respect to the width of this container. So now we know that number of pixels. Now we can move the active puzzle that many number of pixels towards the right. So to do that, active piece dot style dot left, that is change its left value to, let's use string interpolation because we are using a variable which is this offset, and because this offset actually represents the number of pixels, so attach the unit as well. Okay, let's refresh. Let's move this. Nothing happens. Okay, this is not computed style, it's style. Okay, now it's moving. Good. So this part is done. Now we have to figure out, wherever we leave the slider, then it has to check whether the active piece aligns with the placeholder. If they align with the placeholder, then that means you have passed the CAPTCHA, otherwise you must be a bot. Okay, so now we have to work on that functionality. So the first thing is we have to figure out where are we going to define this functionality. That is, when should this functionality be triggered. So basically, when we are moving the slider, the event that is triggered is called input event. But the moment we let go of the slider, at that time, basically we are committing the value. So at that time, the event that is triggered is called change. So we want that calculation to take place when we have committed the value. That is, we have let go of the slider. So at that time, we want to check whether these two boxes align with each other. So let's define this change event. Slider.add event listener, and the event that we are interested in is change. And again, let's define a callback function. Within this function, we are going to call another function, is puzzle solved. We haven't yet defined this function yet, but if we pass the test, if this is puzzle solved function returns true, then we want the alert message which says, let's make it, congratulations, you are a human, else alert, you must be a bot. Okay, so when this change event occurs, this function is executed, which is a if statement. So basically we are calling another function called is puzzle solved. If this returns true, we say congratulations, you are a human. Otherwise it says sorry, let's make it more obvious, sorry, you are a robot, you are a bot, try again. Okay, now all we have to do is that define this function and define the actual functionality within this function. So function is puzzle solved. So the functionality that we have to define over here is, basically we have to check if the left corner of this box and the left corner of this box are exactly at the same pixel alignment, and if the left are aligned, then the rest of the sides are also aligned. Now when we are checking it, obviously being a human, you can't with 100% surety align these two boxes on top of each other. Even if there is a distance of 1 pixel, which is for humans negligible, it's like putting two dots together. So there is no chance for these two boxes to be exactly aligned all the time. So that means we have to leave some wiggle area. That is, if we move on top of these boxes together, it should still return true, because we can't, being a human, by using a slider, we can't all the time align these two boxes together with 0 pixel difference. So we have to leave some wiggle area. That is, if there is a difference of 3 or 4 pixels or maybe 5 pixels, it's still okay. We have still successfully passed the test. So we have to leave that wiggle area as well. The other thing is, the best way to figure out if these two boxes are on top of each other is measure their distance with respect to the top left corner of the whole viewport area. So rather than referencing them with respect to these elements, we are going to reference them with respect to the left of the viewport area. And we can exactly measure the distance in pixels for any element with respect to the left of the viewport area, because each element has a method associated with it by default, and that method is called getBoundingClientReact. And that will return us an object of type DOM-React. And that DOM-React will have different properties: left, right, top, bottom, width, and height. So if we use the left property, it will tell us the distance of this element in pixels with respect to the top left corner of the viewport area. So first of all, we have to get the DOM-React object for this element. So first of all, let's get const piece left. That is the left side of the piece, whatever the element. In our case, it's the box that we are sliding. And we have to measure its distance from the left side of the viewport window. So active piece dot get bounding client react. So this will return us an object of type DOM react for this element, active piece, which is a square that we are currently moving. It could be circle as well, depending on which one of the pieces is active. So anyway, whichever is the active piece, we are getting the DOM react object for that element by calling this function. Now when this object is returned, so basically this part will represent that object. Then we want to use its property called left. So this left will return us the distance in pixels between the left area of this active window from the viewport area. So now we know how far away this active piece is with respect to the left side of the viewport area or viewport window. Now we also have to get the distance of the target piece or the target element from the viewport window, left side of the viewport window. So copy paste. Let's change it to target left. And over here, because it's not an active piece, it's the target element. So have we got a reference to target element? No, let's get a reference to the target element first. Let's check the class name for the target element. So this is target area. Okay. Copy paste. Target area. And the class name is target-area. What could be the problem? Is it over here? Okay, over here. Okay. So let's get target area, target bounding client React, and left. So now we know both of these pieces, how far away they are from the top left, from the left side of the viewport window. So now we have to assign some space for that wiggle area. So we call it tolerance. So that means if the difference is within this range, it's okay, we can tolerate it. So it's going to be 5, that is 5 pixels. So basically this is what it's going to mean. Okay, now we have to check if these 2 pixel values match with each other, including the difference of 5 pixels. So if that is the case, then return true, otherwise return false. So we have to say piece left minus target left. And because depending on if this piece has moved slightly ahead, in that case this value will be bigger than this value and the subtraction will return us a positive value. However, if this piece comes little earlier than the placeholder box, in that case the value of this piece value will be smaller than the box, the dimensions, and in this case it will return us a minus value. So we have to make sure that we put this part with math.absolute. So absolute will give us a positive value. So once we get that absolute value, so now if this value is in the range from 0 to 5, that is if the difference is between the range 0 to 5, then it's okay. We have passed the test. So if this value is less than or equal to tolerance, and the other thing that we have to make is if the active piece which is being moved, if that active piece is actually a puzzle piece, because we know that this puzzle piece is our square and our placeholder is also square. So if circle is moved and basically the circle has round edges but it still occupies the same dimensions of width and height, so technically this part can return true for circle as well. But because the shapes are mismatched, so we should not pass the test. So therefore we have to check and active piece is also equal to puzzle piece as well. In that case, if this whole thing returns true, put it under the parentheses and return the result of that to. So whatever is the result that comes from this, return that result. So this will be either true or false. Okay, now let's test it. Okay, let's move it exactly. Congratulations, you are a human. Okay, let's refresh. Let's move it just. Okay, sorry, you must be a bot. Try again. I don't like this message. It's like saying to the bot, keep trying until I'm tricked and consider you a human. So I'm going to remove this part. Okay, that's better. Okay, now we are almost done. The only thing left is we haven't yet considered that the active piece could be circle as well. So when the active piece is circle, we basically want to move the circle to this position over here, because with this position we have mapped the slider. So if the circle starts moving from this position, there will be a mismatch between the mapping that we have made between the movement in the slider and the movement in the active puzzle piece. So when we click on the circle should come over here and the circle become the active puzzle piece. Then when we move the slider, instead of this square moving, the circle should move. So first of all, let's associate an event listener with the circle puzzle. So circle piece dot add event listener, and the event is click. Now let's define a callback function. So basically what we have to do is that we have to change the value of active piece to circle piece, or we can write this as well, because for this inner function, this is representing this circle. Okay. Then what we want to do is that we have to reset the slider. So slider dot value equals 0, and we have to push the circle piece where our square piece is. So our square piece by default is, let's go to the styles. So where is it? It's 10 pixels from the left of the window, so we have to give this 10 pixels. So circle piece dot style dot left is 10 px. Okay, so this is one part. Let's test it out. If the clicking is working, good. Okay, I think we are done. What part I was thinking is missing? Okay, so we have to basically define the same thing for the square. Now basically, once we make the circle the active piece, and after that we want to give it a try and we want to make this square active piece again, then we need to have the same event associated with the clicking of this as well. So basically, let's copy and paste. Let's change from circle piece to puzzle piece. Add event listener, click. Active piece is this, slider value 0. And over here, let's make puzzle piece dot style dot left. So we are saying the active piece is the current piece, for which this function is executing, or the piece which has been clicked. Then we are resetting the slider to 0. And if the puzzle piece has been moved from its original position, we want it to be moved back to the default original position as well. Slider. Now let's click on it. Again, it moved to its original position. Slide again. Sorry, try again. But if you click, it will move back to its original position. Now we are making the circle the active piece. So click, move the slider, and okay. Now let's move it even further, and technically this should not pass. And now even though these two elements are sitting on top of each other, but because their shapes are different, so it's a mismatch. Hence we should fail the test. So let me let go the slider and say sorry, try again. Okay, so this was the whole logic behind the sliding captcha. I hope you liked it. I definitely did. Now this sliding captcha was implemented with only front-end logic. But in future, we might create another one with the backend involved, which will basically do the validation for the security purposes. So that sliding captcha will be even more secure than this one. So if you are interested in that version as well, do let me know through the comments, and hopefully very soon we will implement the other version with the backend as well. In the meantime, happy coding. Please don't forget to comment, like, subscribe, and share.